Hello grade 10s. So this is a geometry revision before you write your June exams. So what is going to happen here is that we are going to revise everything that you need to know with regards to geometry, and I'm going to give you my tips and tricks on how to answer your geometry question. Okay, this is not a hard topic, but it has to be taught in a certain way in order for you to master it. And don't forget to like, comment, and subscribe to the channel for more videos like this. Let Jane Tutors become your academic companion and help you navigate your academics. And yeah, let's get right into it. So this is a grade 8 document, as you can see, but in order for us to pass, we need grade 10's work, which teachers in grade 10 don't take into consideration. They just assume you understood it in grade 8 and grade 9. You were taught these topics and there's no need for them to go through it. But I'm here to help you understand these basics in order for you to master geometry. When we go to these exams, that paper 2, the geometry part, you must just take it by storm. Show it who you are. And yeah, let's do that, guys. This is exciting. Okay, number 1, we're going to learn about two lines that are intersecting. Two lines intersecting. Okay, so when two lines are intersecting is when two lines are crossing each other. Intersecting, we'll say it's crossing. So these lines are crossing each other. Can you see when you are walking on a road, let's say, and then there's a road going this side, other one coming this side, other one coming this side, and the other one coming that side. So here is what we call an intersection. So these lines are intersecting. So intersecting lines are lines that actually meet. Okay, this one meets this one, this one meets this one, this one meets this one, and this one meets that one. But you understand, it's an intersection. So we have lines that intersect. Now number 2, when they intersect, it does not necessarily mean that they cut each other into half. Okay, so they're just intersecting. It doesn't mean there is a half. It's just an intersection. But when they bisect each other, which is this part, then they are cutting each other into half. Okay, as you can see here, they've cut into half. So PO, this part is equals to this part. Okay, so this line are bisecting. Okay, one line intersects another exactly in the middle. So we can just have something like they meet here. It's not in the middle of this one that is lying down, the first one. So this one and this one are just intersecting. But when we come this side, we say they are meeting exactly at the middle. So when they are meeting exactly at the middle, this one equals to this one. Then you will find out that this one also is equals to that one. Okay, so we have to know intersecting lines are just lines that are crossing, and then bisecting lines, when lines are bisecting, there is one that intersects exactly in the middle. This one is intersecting in the middle of this one. Okay, so that's another thing to keep in mind. And now we're going to be talking about parallel lines. Now, parallel lines are lines that will never meet. Lines that will never meet no matter what. These are parallel lines, not lines like this one is like this, this one is like this. They are not parallel. Okay, parallel lines are straight lines. They can either be like this or they can either be like this, but they never ever meet. Okay, one thing about parallel lines, they will never ever meet. So that's what you have to know. Again, if they say parallel lines, those lines are never going to meet. So AB is parallel to CD because they will never cross each other. Okay, and then another thing you have to know is perpendicular lines. Like wherever you get this, we have a 90. Okay, everywhere. So this 90 forms right angles, triangles. Okay, those 90 degrees form right angles, triangle. Just draw it here. We have two, it's 90 there and it's 90 this side as well. That is what you have to know as well. Very, very important. So perpendicular lines form a 90-degree angle with one another. And then RS, which is this one, is perpendicular to this one. Always this one that is going straight is perpendicular to this one that is laying flat. So those are the things that you need to familiarize yourself with. Now again, let's look at types of angle. An angle that is greater than 0 but smaller than 90 is acute angle. Let's say we have a Cartesian plane here. This is 360, this is 90, this is 180, and then this is 270. Here 0 starts here. So any line, any angle here is an acute angle. So a triangle that goes this way, this is an acute angle. A triangle that goes this way, this is an acute angle. It has not reached 90. Maybe this is 85 degrees. Okay, so that is an acute angle. And then a right angle is this one. This one that is standing at 90 and then going straight. And then we have like that. So that is an right angle. If we have anything like this that has been cut like this, and then here we have 45 degrees. For us to get this one here, we have to say 90 minus 45 equals to this one here. Okay, that's what we do always. It's very important that you know this type of things. Very, very important. So that is how we do that. So that is a right angle. And then an obtuse angle is an angle that is here, greater than 90 but smaller than 180. So anything like a triangle like this is an obtuse triangle. Okay, this angle here is greater than 90 but smaller than 180 degrees. So that is an obtuse triangle. And then we have a reflex, not a reflex, a straight line. So a straight line is when we are here. A straight line like this is equals to 90 degrees. So if there is a line going up here and this line is called 85 degrees, then to get this one, you say 180 minus 85. They give you, all straight lines give you all straight lines are equal to 180. Okay, and then we have a reflex. A reflex is greater than 180 but smaller than 360. So it's like this side. Okay, so it's greater than 180 but smaller than 360 or 270. It's just here. You can just be here. Okay, and then there's an angle on top there. Now we're gonna talk about a revolution. A revolution is a point around a circle. This is 90, this is 90, this is 90, this is 90. They all make 360. So they are revolution angles around a point. All right, so we are done with angles. Now let's see adjacent angles. So here, two angles with a common vertex and a common arm, and the two angles lie on either side of the common arm. Okay, so this angle and this angle, they are adjacent. Okay, here and here. So these two angles are adjacent. So always remember that two lines that share a common vertex and a bottom and a common arm are adjacent. There's something that like here where we have an acute angle, when there are two angles like that, so this is how we see that they share the same vertex and the same arm. Okay, yeah, so that's how we see adjacent angles. And then we have to know complementary angles sum up to 90. As I had previously said, that this is 90 degrees. These two angles are supplementary. This is 45. We're going to say 90 minus 45, and then we get 45 here. So 5 plus 5 is 10. 0 carry 1. 4 plus 4 is 8 plus 1. That is 90. Okay, so they make up 90. Any angles that when you add them together they give you 90, they are complementary angles. Okay, and the supplementary angles sum up 180. I told you if you have a straight line, and here we have angle 30. Let's make use of this one that we already have here. This, they are on a straight line, and when you say 145 plus 35, 5 plus 5 is 0, we carry the 1, and then 1 plus 4, that is 5, 6, 7, and 8. So we have 8, and 1 plus this here is 0. We have 180. So we know that these angles are supplementary. Okay, anything on a straight line, those angles on a straight line, and they add up to 180, they are supplementary. Okay, so angles on a straight line are supplementary. That's what reason you will give here. They are both equal to, when you're trying to find another one, let's say you didn't have this one but you had this one, you're going to say 180, let's say this one is x, we'll say x equals to 180 degrees minus 145 degrees. Okay, because angles on a straight line are supplementary. Okay, or you can just say because angles are, you can say supplementary angles, that is the reason why, or you can say angles on a straight line, that is your reason. So then x will be equals to 35 degrees. Okay, so that's what you have to know. And then we're going to look at vertically opposite angles. If two lines intersect each other, the vertically opposite angles are equal in size. So remember, we talked about intersecting lines that cut each other like that. So if those lines cut each other like that, which means this one is equals to this one, and then this one is equals to this one. We find them a lot in like rhombus and parallelograms. You will see we find vertical opposite angles a lot. So yeah, in squares, and like we'll just see about it when we're still explaining. So those angles are vertically opposite. You'll find them everywhere. Always be aware of vertical opposite angles. And then angles around a point, revolution, as I have said. When angles add up to 360, we have a point here. All the angles here need to add up to 360. Okay, and then they are called revolution, as we have already done that. And then we have parallel lines. And then we have parallel lines. Whenever we have parallel lines, okay, whenever lines are parallel, either in a square, in a rectangle, whenever we just have parallel lines, guys, corresponding angles, alternating angles, and co-interior angles will always be present. Okay, that's what you have to know. So corresponding angles are the ones that make up F. Okay, so let's go from here to here. So D and H are corresponding angles. And then this side we go like this. C and G are also corresponding angles. Okay? And then when you do it upside down like this, E and A are corresponding angles. And then let's just erase here. And then we can do it again upside down like this. F and B are corresponding angles. They make F. Okay? So let's look at alternate angles. They make, is it an N or a Z? They go like this, go like this, go like this. So C and F are alternating angles. And then they also go this way, where we have E and D. They are alternating angles. And you can also go C and F go upside down. F and C also does their own thing, and then that is E and D. They make their own thing. And then these ones are vertically opposite angles. Okay, we have like that, they're intersecting, and this ones as well, they're intersecting. So we have vertically opposite, E equals to H, F equals to G. Okay, so remember that we have intersecting lines, and then we have parallel lines. They never meet. So AB and CD are parallel lines. And then another thing we have to know is co-interior angles. So angles between parallel lines are co-interior. So D and F are co-interior, meaning they have to add up to 180. So if this is 70, for you to get F equals to 180 degrees minus 70 degrees. So you find co-interior angles inside all this, many of the shapes of the squares, rhombus, rectangles. You will find co-interior angles, alternating angles, and corresponding angles, as long as there are lines in between. So here, to prove that lines are parallel, one of the following must apply. A pair of corresponding angles must be equal, or a pair of alternating angles must be equal, or a pair of co-interior angles must be equal to 180. So that is how we know that, okay, these angles are actually parallel. And then let's see, calculate the value of the variables and provide reasons. Okay, so here we are looking for y. Ne? Remember that this is a straight line. So we are going to use y equals to 180 minus 86. Y, angles on a straight line. Okay, that is the reason that we can use, or we can use supplementary angles because they are on a straight line. All right, so that's where we have y equals to 94. Okay, that is very easy, right? When you know your work, it's very easy to answer anything. Okay, so here we have vertically opposite. So 2x plus 40 equals to 86. Guys, vertically opposite angles are equal, exactly equal, the same. So here we have to solve for x. So 2x equals to 68 minus 40. So that is where we have 2x equals to 46. And then we divide by 2 both sides to cancel this 2. Then x equals to 23. Okay, so where you see 2, you're going to do 23 plus the 40. 23 plus the 40 to get that angle. So when we do it, we will say 23, let's say, divided by 2. So 3 minus multiplied by 2, that is 6, and then 2 multiplied by 2, it's 46. So 46 plus 40, yeah, so we have 46 plus 40, right? Let me do it here. 46 plus 40, 6 plus 0 is 6, 4 plus 4 is not 4, sorry, 8. So we have 86 here. And then remember Z, so K is also equals to 86. So here we have to prove if these lines are parallel. Of course, they are parallel because we have that F effect. So we can say that they are parallel. Okay, and then here we have to prove if these ones are parallel. 103 plus 103, does it give us 108? No, it gives us more. This is 602, this is 206. So no, they are not parallel because these co-interior angles do not add up to 180. Okay, so you look, if you want to prove that lines are parallel, you look for co-interior, alternating, and corresponding angles. Now let's look at this triangle. So a triangle where all sides A, B, and C represent the angles. So we have angle here, here, and here, okay, in this triangle. And we're going to do types of triangle. We have a right angle triangle. Here, this angle is equals to 90. In a triangle, guys, no matter how is the triangle, the interior angles of that triangle must be equals to 180. So this angle plus this angle plus this angle must be equals to 180 always. If this one is 80, this one is 60, then this one, let's say it's x, find x. We're going to say x equals to 180 minus 60 degrees plus 86 degrees. Let's say this is 86, and then we are going to get the value of x. Okay, so just know the interior angles of a triangle are equals to 180, and that is going to be your reason when you're trying to find this other angle. You're going to say interior angles of a triangle are equals to 180, hence why you did that calculation. So if one angle there is equals to 90 degrees, then that angle is a right angle. I showed you where I was doing this angles, and then we did acute angle, and then we did obtuse, angled, triangled as well when I was showing you guys, and then we do isosceles, and then we have an isosceles triangle. In an isosceles triangle, that's where two sides are equal. So if they do like this, it means this angle and this angle are equal, not this one. Meaning, if this angle is 60 degrees, this one is also 60. And then to find this one, maybe it's x, we'll say x equals to 180 minus 60 plus 60. So you need to be able to, even inside those tricky what we call them images, you need to, if you are given something like this and then you have triangles, this bisect each other, so you have isosceles triangle, you have other two isosceles triangles here, you see. So these are some of the things that you have to know. You can identify these things inside squares, rhombus, and whatever, like you are able to do that. And then when we talk about equilateral triangle, is where this side, and this side are equal, meaning this angle and this angle and this angle are equal. Okay, so taking 180, dividing it by 3 will give you the same answer. So they are equal to each other. That is what you have to know as well. And then we have scaling triangles. Okay, all the angles are not equal. And then properties of triangles. In a triangle, the longest side is always opposite. The longest side is always opposite the biggest angle. Okay. In an isosceles triangle, two angles opposite the equal sides are equal. Another thing we have to know, guys, is like when you have something like this side is equals to both these angles. This angle plus this angle equals to this side when you have a triangle. That's another thing that you have to know and master, that this angle equals to two of these angles. Okay, that is what you need to know at all times. In equilateral triangles, all angles are equals to 60. This one that I showed you, that all the angles are equal, is very important that you know that. And then the sum of interior angles of any triangle is equals to 180. So this angle plus this angle plus this angle need to give us 180 when we add them. Okay, and then the exterior angle of a triangle is equal to the sum of the two opposite interior. So this is equals to this plus this, because this is the exterior angle is equals to the sum of two interior angles, which are this one. Interior inside the triangle, exterior outside the triangle. Okay, and then Pythagoras. When you have a right angle, you're always able to exercise Pythagoras. Only in a right angle triangle. You cannot make use of a Pythagoras anywhere else except in a right angle triangle. Okay, so this is the longest side, always the hypotenuse is sometimes called the R. This B is also can be also called the X, and this C can be the R, can be the Y side. Okay, so always know that. Okay, because let's say this is R, this is Y, and this is X. We do this again in trigonometry. R squared equals to B squared plus C squared, but Y squared equals to R squared minus, I made a mistake here. I did R and A's and B and what. So R squared equals to X squared plus Y squared. And then when we want our X, we'll say R squared minus Y squared equals to X squared. And then R squared minus X squared equals to Y squared. So this is how you get the other sides of a right angled triangled. Okay, that is how you do it. And then we're going to look an area of a triangle. So when you're trying to calculate the area of a triangle, this height, this is the height. If you're given this one, you'll be given this is the height. You are given this one, this is the height. Okay, they will give you the height. So it's 1/2 base. Let's say base is 3. You're going to say 3 multiplied by the height is 4. You're going to say 4. So this is how you calculate the area of a triangle. Any triangle, you just need its height and its base, and you are done. Okay, you can calculate that. So here for right angle triangle, the Y is the height, then the X part is the base. Those are the things that you need to familiarize yourself with. It's very, very important. And then here, calculate the value of X, Y, and K in each of the triangles. So here we have to calculate that one. So we'll say angle R equals to 180 minus 65 plus 54. So let's do 65 plus 54. 5 plus 4, that is 9. 5 plus that is 11, so that is 119. we know that we are dealing with r equals to 180 minus 119, right? So we have 180 minus 119. So we cannot subtract 9 from 0. We're going to borrow here. We're going to have 7 and then borrow the 10. So we have 10 minus 9, that is 1. Then here we have 7 minus 1 is 6. Then we have 1 minus 1, so we have 61. Now r is 61. Let's see if my mental math is working. So here we will have 65 plus 54 plus 61. So 5 plus 10. 5 plus 4 is 9, plus 1 is 10, carry 1. Right, 0, carry 1, and then 6 plus 6 it's 12, and then 5 plus 1 is 6. So 12 plus 6 is 18. So they add 180, so r is 61. And then we are going to look at this one. What is it equal to? So y equals to 44, because opposite angles of a triangle. So opposite angles of a triangle, you can say they are equal. Okay, and then k, this one, is equals to this one plus this one, right? Unless they have stated what this triangle, if they have not stated, we say opposite angles of a triangle are equal. Okay, and oh, this one, yeah, this one shows that this triangle is like this. Okay, because of these parallels they've given them to us, so we can say this and this are opposite, so they are equal because of those two lines. And yeah, here we apply Pythagoras. So this is 4, this is 3 to get f. The final answer is 25, so we square root and then we get 5. So always square root. If we have 2 squared, when we square this ones cancel each other, and then the answer is just 2. Okay, know that. That's how you can use a square root to get rid of an exponent. For that exponent has to be a cubed. That's how you do it. Calculate the area of the following triangles. You have the height and the base, so you can calculate the area of that triangle. Yeah, and you can do this one as well. There is the answer. So yeah, we're going to quadrilaterals. Types of quadrilaterals. We have a square, meaning in a square, always in a square, all the angles, the interior angles are equals to 90. Okay, so this one they bisect, meaning we get vertically opposite lines there. Remember guys, I told you, you see these things everywhere. All the sides are equal in length, so this one is equals to this one, equals to this one, equals to this one. All the sides are equal in length. The opposite sides are parallel. This one is parallel to this one, so means this one are co-interior angles, this ones are co-interior angles. Okay, this one and this one need to make up 180, this one and this one need to make up 180 degrees, and this one and this one are also parallel, so this one and this one have to make 180, and this one need to make 180. Remember parallel lines guys, and then we have something like this as well. So this angle is equals to this angle as well. You see, like so many things can be applied here. The only thing that we cannot do is the f here with a square, but others co-interior and we can do. And then the diagonals bisect perpendicularly and bisect the angles. The diagonals are equal in length. So this line is equals this line is equals to this line, so they intersect. When they say they bisect, sorry, when they intersect, they just intersect. When they bisect, they cut each other into half. So those diagonals inside a square, they cut each other into half, as I have shown you. So this, it also cuts the angle in half. So this is 90, so we have 45 here and 45 this side. Okay, and then in this triangle, this angle is equals to this one there. So it's 45, it's 45, and then you can get this one. Because they are isosceles triangles, equal two sides. Okay, I hope you are learning this. And then we have a rectangular. Diagonals bisect one another as well. So this side is equals to this side, and then this side is equals to this side. As long as you see bisect, that's what you know. The diagonals are equal in length, but they do not bisect this angle. They don't cut these angles into half, okay? And then all angles are 90 degrees. And then opposite sides are parallel. So this side is parallel to this one, and then this side is parallel to this one. And then let's look at parallelograms. Opposite sides are parallel, so these ones are the only parallel ones. And so you will find cointerior angles here, and then you will also find your Z in there, okay? And then these ones are also parallel, so you can find cointerior angles and the Z in there. And then opposite angles are equal, so here opposite angles are going to be equal, okay? And then diagonals bisect each other, meaning they cut each other into half. That's again what you have to know with parallelogram. This one and this one, we have opposite angles. Now with a rhombus, all sides are equal in length. This side plus this side plus this side plus this, just like a square, they are equal in length. Where these diagonals bisect, they form 90 degrees. So this is 90, 90. Everything is 90 there. And then opposite sides are parallel. This is parallel. This is parallel. So here, when we talk about opposite sides are equal, we talk about this one, and this one are equal, and this one and this one are equal. Always know that, guys, okay? That's how you will pass this thing. Yeah. And then you're going to go to a trapezium. One pair of opposite sides is parallel, so only this side and this side are parallel. So that's all we have to know, okay, with regards to trapeziums. And then with a kite, pair of adjacent sides are equal. This and this are equal, okay? Just know that. One pair of opposite angle, and this side and this side is equal. This side and this side is also equal, guys, in a kite. And then here they form 90 degrees. The diagonals of a kite, where they bisect, they cause 90 degrees. One pair of opposite angles is equal. This and this are equal, but this one are not equal. They just can make 180, not equal, okay? They're not the same. Yeah, the sum of the interior angles of a quadrilateral is equals to 360 degrees. So everything you see here, this needs to give you 180. This one, like all these shapes, they need to give you 180. The angles inside must give you 180. Okay, calculate with reason the value of x. You see, you have you can you see that you also have Yeah, you also have this 3x and this y. Like, those are some of the things that you have to see, guys. So 100 plus 3x. So this 100, this 2. Remember, these lines are parallel, so we can do co-interior angles. So this 100 plus this equals to 180. That's how you'll be able to solve for x. So those are the things that you should keep in mind. We have parallel lines, so that's how we're able to find the value of x. And then x equals to 20. Now, when we do, and then you're going to say 320, right? So it's 20 times 3, 0, 60, like that. So we have 60 here, and then we can have something like this. Yeah, so let's continue. And then 3x equals to y, okay, because of this angle equals to this angle, right? Meaning this one equals to this one, okay? That is what you should know. And yeah, the reason is still alternating angles. So y equals to 60, and then k equals to 100. Yes, that is how you do this type of question. And then here for k is 90, diagonals bisect. And then what else? Y squared equals, so we have right angles. This is a right angle, this is a right angle, this is a right angle, and this is a right angle. So we can use Pythagoras to look for sides. Yeah, thank you very much, guys, for watching. Let's see, are we done? Yeah, from there you need to know how to calculate. This is another example that you can look into. And sometimes they like to bring in circles in grade 5, so you just to know what is a chord, a diameter. When you have a circle like this, the lines that go from this end to this end is called a diameter. Okay, and then if is this the one from here to center, it's called a radius. That's another thing you need to know, because the area and circumference of the circle also you can know about that. Let's just look at this and look at the midpoint theorem. So know that BC is 2 times DE, okay? Always BC is 2 times DE. That is the midpoint theorem. So this is the document, guys. I'm going to link in the description box, and you can just download it by clicking on the link and try to do these questions. There are solutions here, I think. Let's see. Yeah, there are solutions, so you can use this. Was downloaded from the Stanmore Physics website, so you can use it to practice for your exam. And another tip that I have for you, when you're practicing geometry, when you are answering a geometry question, do not look at the questions first. Look at the drawing, analyze it, write every answer that you know, okay? And then after doing that and reading the statement, and then you can go and answer. But when you go to the questions first, you are going to be confused on what are they really looking for. So don't look at the structure, don't look at the questions first, look at the structure, and then after that, that's when you answer. That's how you master geometry, okay? You know this thing, go into that structure, write everything you know by looking at the statements, and this is equals to this, this is equals to this, that what I know and have been taught. And then after that, that's when you'll answer your questions. Thank Thank you very much. Until the next video, don't forget to like, comment, and subscribe to the channel. Share with your friends and family. Until the next one, bye.